All right, we're going to finish up this last section of chapter 4, section 3, where we're going to discuss hyperbolas. So again, you don't really need to have this sort of definition fully understood, right? I mean, just like with parabolas, just like with ellipses, you don't really need to know that it's the set of all points where if you take the distances from the foci, you get the positive constant. That doesn't really matter for the sake of this lesson, but what you should know is the shape it makes and the parts of the parabola, which I'll discuss in the next slide. All right, so a hyperbola. What a hyperbola looks like is you're going to have two of these branches that are kind of like U-shapes, right? Similar to a parabola, but you're going to have two of them, all right? And you can see in this image down here in the corner, one of them is opening upwards, right? So like that, and then the other one is opening downwards, right? So you're going to have two of them. Similarly, you can have them opening left and right. So for example, something like that and something like that. That is a horizontal hyperbola, right? So it can either open up, down, or left, right. All right, and you can see in this image right here, we have a center, right? So this is the center right here of our hyperbola. And it is what it sounds like, right? Your hyperbola, the two little curves are going to be centered around there, right? And similarly in the horizontal one, it's going to be right in between those 2 points. It's going to be directly in between your vertices, right? I have a vertex right here, and I have a vertex right here. And just like with an ellipse, the distance from the center to the vertex is your A value, all right? And you also have the distance from the center to your foci, right? It's not really labeled in this one, but that is called the focus. That's another focus right there. The distance from the center to the focus is your C value, just like an ellipse, all right? There is a B value not pictured here, but it does show up in the next slide. I'll explain that in a second, but some other things that you should know, you have this right here called the transverse axis. The transverse axis just connects your two vertices, and that's where your center is, all right? Your center is directly in between them, all right? So a couple things lie on this part of our graph right here, right? This line, all right? We have our transverse axis, we have a center, our vertices, and our foci, all right? And then our branches are going to go outwards from there, right? And you notice from here, your focus is inside of your two little U shapes. That's all for this slide. I'll explain more about hyperbolas in the next slide. All right, so this really outlines our standard form of a hyperbola. Notice in those little yellow boxes, it looks very, very similar to another equation that we've seen before, right? They look like the equation of ellipses, right? Hopefully you notice though that the only difference is that in between I have not a plus like an ellipse, but I have a minus, all right? Otherwise, everything looks pretty much identical, all right? Only thing is, if you remember with an ellipse, your A value is whatever was bigger, all right? But in a hyperbola, your A value is whatever shows up first, right? So if it's an x squared over a squared, A is with the x, that means it's a horizontal hyperbola. And in the second one, the a squared is with the y squared, so I know it's going to be an up-down, a vertical hyperbola, all right? So a squared is just whatever's first, right? Sometimes A is smaller, right? Sometimes you're going to have a 4 down here and then a 100 over here, right? So that doesn't really matter. It's not a matter of which one's bigger like an ellipse. It's just whatever shows up first, all right? Now, you get your C value, like we talked about in the last slide, from this little formula right here, right? Notice we also saw something similar to this with an ellipse, just this time we have a plus instead of a minus, right? So things kind of look opposite from a hyperbola as they do an ellipse, right? So this was a minus with an ellipse, this was a plus with the ellipse, and it's going to be the opposite for hyperbolas, right? This is a plus here, and this is a minus here. All right. Now, analyzing these little graphs over here, right, we get some more information that actually help us graph our hyperbolas. All right. We have information that we already talked about, right? Our centers right here. We have vertices. We have foci. What I didn't talk about are the co-vertices, right? They show up. They're going to be off our graph, though. It's not really necessary that we plot them, but the B does give you important information regarding the asymptotes, right? The asymptotes are these dashed lines, right? You guys have seen asymptotes before, but they're going to be these little dashed lines that your graph approaches but never touches, all right? And we get our asymptotes, the equation of those lines, from our B value, right? So that's where our co-vertex is useful, right? And then so from one end to the other of your co-vertices, that's going to get you what we call the conjugate axis, right? It's not super huge in this lesson. It's more important that you know what the transverse axis is, right? So from one vertex to another, right? That is the transverse axis, and that's where most of the important stuff lies. All right, you notice that we have the same exact thing over here for a vertical, just everything looks flipped, right? So my vertices now are up and down, my foci are up and down, my co-vertices are side to side, but I still have asymptotes, which again, you're going to use using your A and B value, which I'll talk about in the next slide. All right. Now your asymptotes, if it's a horizontal hyperbola with a center at 0, 0, it's going to be y equals plus minus b over ax. If it's a vertical hyperbola, so up and down, right? Remember, horizontal is left and right. If it's a vertical, then it's going to be plus minus a over bx, right? We do give you a formula for the asymptotes, but we're not going to tell you which one's which. One way that I like to remember which one is which is a horizontal hyperbola looks like this, right? And a vertical hyperbola looks like this. All right, you're probably like, well, I already knew that. Why are you telling me that now, right? This can kind of help you determine where A and B are going to go. Just because if you remember your slope formula, remember, that's really what this represents. The B over A and the A over B, they represent slopes of your asymptotes. If you remember your slope formula, y2 minus y1, your y's are on top. Over x2 minus x1, your x's are on the bottom. So if you're looking at a horizontal hyperbola, notice that B is going to go with your y, and the B is on top. A is going to go with the x, and A is on the bottom, right? So it's always y over the x, right? And in this case, B is with the y, A is with the x, right? Vertical, it's going to be the opposite, right? A goes with the y, so A goes on top. B goes with the x, so B is on the bottom, right? So A over B, right? So no matter which way you look at it, the whatever goes with the y should be the number on top, right? And that's just one way that I like to think about which formula is which, right? Which one goes with the vertical, which one goes with the horizontal. The other way that you can do it is you can take your conjugate axis or your co-vertices and kind of figure out the asymptotes from there, right? If you look at the previous slide, there's like a little box, like a dotted box, and connecting the corners of that boxes gets you your asymptotes, right? I think this way is simpler, so this is how I usually stick to it. All right, let's actually put this into practice. All right, so just like with ellipses, we want these set equal to 1. This one's not equal to 1, so I'm going to go ahead and divide both sides by 16. All right, so divide everything by 16. 4 and 16 simplify to 1/4. So we get x squared over 4 minus y squared over 16 equals 1. All right, and then that is a hyperbola in standard form. Notice now that the x squared is first. If x squared is first, then it is a horizontal hyperbola. All right, so opening left and right. Now let's try to find all of our necessary information, right? We're asked for our center, and this center is at 0, 0. We know it's at 0, 0 because we don't see an h and a k, right? If you look a few slides later, you're going to see that there's a formula for a hyperbola not centered at 0, 0, and there you do have an h and a k, just like you did with an ellipse. All right, so there's our center. As you get this information, I would plot it. So I have 0, 0 right there. Now let's find our vertices. All right, so my vertices, I'm going to take my a value, right? Remember, a goes with whatever's first. So that means a squared is 4, and that makes a 2. All right, and since it's a horizontal, I'm going to go 1, 2 units over, and 1, 2 units over. So it's going to be something like that, something like that. And then my vertices are going to be at 2, 0, and negative 2, 0. All right, now let's find our foci. All right, so our foci, and then with that we use this little formula, c squared equals, this one's going to be a squared plus b squared. In this case, b squared is 16, and let's just say right now that b is 4, right? That's not going to help us with this right now, but it will help us in a second, right? So b squared is 16, and a squared is 4, so I know that c squared is going to have to be 4 plus 16, which makes c squared 20. And when I go to square root both sides, I get c is the square root of 20, but simplified, we get c equals 2 square root of 5. All right? So that means from our center, we're going to be 2 square root of 5 units from there, right, to the left and the right. I would look at the square root of 20 and estimate, right? It's between the square root of 16 and the square root of 25. Which means it's between 4 and 5. So I'm going to go about 4.5 units over, right? So 1, 2, 3, 4, and a little more. And then I'm going to go backwards 4 and a little more, right? 1, 2, 3, 4, somewhere right there. And then those are your foci. As ordered pairs, that's going to be 2 square root of 5, 0, and then negative 2 square root of 5, 0. All right. Lastly, we want to find our asymptotes. And again, we use our little formula y equals plus minus. It's either a over bx or b over ax. You're just looking at whatever's with the y. And in this case, b is with the y, so that means it's plus minus b over ax, which means it's going to be 4 over 2, right? So y equals, or I'm sorry, plus minus 4 over 2x. Simplify, that's going to get you plus minus 2x. All right? And graphing those is actually going to get us our final shape, right? So plus minus 2x means I'm going to have one equation that's a positive 2x, which means I'm going to have a slope of 2. It's going to look something like that. And then y equals, all right, so this is that equation, right? Y equals 2x. I need a y equals negative 2x now, which is going to go down 2 and over 1, right? So it's going to look something like that. All right. And then so now this, from your vertices, this is enough information, right? You don't need to find additional points or anything. It's going to look something like that. And something like that, right? Approaching but never touching the asymptotes. All right. And that's enough information to sketch your hyperbola. I'm going to go ahead and find a little bit more information just because this is the first of its kind. You're not always going to have to find this information, but just so that you guys know what they look like on a graph. The b value represents your co-vertices, and that means you're going to go 4 units up and down, right? So I have a co-vertex right here and another co-vertex right here, all right? Another thing that we have is the transverse axis, right? Remember, the transverse axis is from your vertex to the other vertex, and that means your transverse axis, right? I'll write it down here, right? Transverse axis. The length is 4, right? 4 units, right? 1, 2, 3, 4, right? 4 units. We have a conjugate axis length of 1, 2, 3, 4, 1, 2, 3, 4, so 8 units, right? So conjugate axis has a length of 8, right? But again, that one's not super duper important, right? We don't really pay much attention to the conjugate axis and the covertices. But yeah, that's just so that you guys are aware there is that extra stuff for you guys, right? And then you'll see that if you draw a little box connecting your covertices and your vertices, your asymptotes do go through them. All right, so that's what I was saying before about like if you forget which one's which, right? Whether it's B over A or A over B, you can also just draw a little box and then connect the corners, and then you still get your asymptotes. Right, I'm not going to go that far into detail for the rest of these problems, but that's just so that you guys know what every single part of it represents, right? All right, so this one I'll stick to what we have, or what we're being asked, sorry, right? So then let's make sure first that it's set equal to 1. So I'm going to divide everything by 100. All right, and then 25 and 100 simplify to 1 over 4. We end up with a y squared over 4, and then 4 and 100 simplify to 1 over 25, so I end up with an x squared over 25 equals 1, all right? And then this is enough information to know which way it opens, right? Since y squared is first, it's going to be an up-down hyperbola, and that means a is underneath the y, right? Well, a is always going to be first anyway, right? But in this case, a squared is 4. I know that a is going to equal 2. Similarly, I know that b squared is 25, and that would make my b value 5, right? That's going to help us in a little bit. Let's find the information that we're being asked, right? So my center is going to be at 0, 0. Again, there's no h and k over here, so this is just 0, 0. And then let me plot that on the graph. So 0, 0 is right there. All right. Your a value of 2, that's going to tell you how many units from the center you're going up or down. All right, so if it's a vertical, I'm going to go up 2 units and down 2 units. And so let's write those points as ordered pairs. All right, so my vertices are going to be at 0, 2, and then I have more vertices at 0, -2. All right. More information that we can find are the foci, right? Our foci, we use this little formula, c squared equals a squared plus b squared. In this case, it's going to be 4 plus 25, which means that c squared is 29. And then when you go to square root both sides, we get c is plus minus the square root of 29. That means I'm going to go up and down square root of 29 units. Square root of 29 is more than the square root of 25. So I know it's going to be a little bit more than 5, right? So 1, 2, 3, 4, 5, and a little more. And then 1, 2, 3, 4, 5, and a little more. All right, so that means my foci are at 0, square root 29, 0, negative square root 29. All right. We also need our asymptotes. Right, your asymptotes are going to be y equals plus minus. It's going to be plus minus whatever goes with the y. And in this case, a goes with the y, so that means 2 is going to go on top. B goes with the x, so 2 over 5x. All right, so that means I'm going to have a line going with a slope of 2 over 5, so up to 1, 2, 3, 4 over 5, right there. So I know it's going to go something like that. And then it's going to go down 2 over 5, so 1, 2, 3, 4, right there. Somewhere right there, right? And then we can plot that line. All right. And then that's enough information to sketch your hyperbola. So it's going to be something like that. All right, so making sure to get close to the asymptotes but never quite touching it. But yeah, that's every part of our graph. Now these are hyperbolas that are not centered at the origin. Just like with ellipses and just like with parabolas, you're going to have an h and a k, and that's going to determine where the center is. But the a value and the b value you get exactly the same way. It's just the a value is then going to tell you from the center whether you're moving up or down or left or right that many units. The asymptotes of a hyperbola, we are giving you guys this formula. Again, you guys are just responsible for knowing which one is horizontal and which one is vertical. But again, if you look at these two formulas, right, the only difference is the b over a, and I had already taught you guys earlier this lesson how to determine which one's going to go on top, right? So whatever goes with the y is the one that's on top. But otherwise, everything is the same. H is always with the x, k is always with the y. All right, so let's look at this one. All right, so let's first determine our center. Our center is going to be, all right, 3 goes with the x, so it's going to be -3. 2 goes with the y, so it's going to be a -2. It's always the opposite of the sign that you see. And then let's go ahead and plot that point. All right, -3, -2, 1, 2, 3, 1, 2. It's going to look something like that. And then because I know the y squared is first, it's going to be an up-down hyperbola. And that would mean 9 is a squared, and that would make a3. So that means I'm going to have to go 1, 2, 3 units up, and 1, 2, 3 units down. So it's going to be something like that. Up 3 units, down 3 units, right? So then we have vertices at -3, 1. It looks like that top one is. And then the other one is at -3, -5. All right, now let's find our foci. Remember, for the foci, we always use c squared is a squared minus b squared. I'm sorry, plus b squared in this case. And it's going to be 9 plus 4, so 13. So c squared equals 13. And then when you go to square root both sides, I get c is plus minus the square root of 13. That means from our center, I'm going to go up and down square root of 13 units, which is close to the square root of 16, so it's going to be a little less than 4, right? So 1, 2, 3, 4 and a little more, 4 and a little more, right? So somewhere right there. So that means if you're looking, your x value of your center is staying the same. Your y value is the one that's changing. So it's going to be -2 plus minus that value. You're going up and down square root of 13 units, so you're attaching it to the 2, right? If it was a horizontal, you would have attached it to the x, right? But we're going up and down. Lastly, we find our asymptotes, right? Which is going to be y equals k. Our k value is -2 plus minus the letter that goes with the y is a, right? So a is 3, and then b goes with the x. I know that 4 is b squared, so that means b is 2. All right, so 3 over 2, x minus h is going to be x plus 3. So that's the equation of our asymptotes. To actually graph it, all you have to do is go to the center, which we already plotted, and you're using 3 over 2 as your slope. So I'm going to go up 3 units over 2, graph that line, and then I'm going to go down 3 units over 2, and graph that line. And that's enough information to sketch your hyperbola. All you need are your vertices and your asymptotes and your center. And then that's enough information. So your hyperbola should look something like that. All right, last one of this lesson, same idea. It's set equal to 1, so all we have to do to find the center is look at what's inside of our parentheses. 3 is with the x, 2 is with the y. So I know my center has to be at 3, 2. Let's go ahead and plot that point. All right, so 3 units, 1, 2, 3, 1, 2. It's going to be somewhere right there. All right, and then because x squared is first, I know it's going to be horizontal. It's going to be something like that. All right, My a value, we don't see a fraction here, so I assume it's over 1. That means 1 has to equal a squared, and that means a is 1. So that means I'm going to go to the left one and to the right one to find my vertices. That means my vertices are going to be at 2, 2 and 4, 2. Our foci, we're going to have to do c squared equals a squared plus b squared. And then those we get directly from under our x and y, so it's going to be a 1 plus 9. So I get c squared is 1 plus 9. That means c squared is 10. And then when we square root both sides, I get c is plus minus the square root of 10. So that means I'm adding square root of 10 to the x, right? So to that number, it's going to be 3 plus minus the square root of 10, comma 2. Right, so that means when we plot this, I'm going to go square root of 10 units from our center. Square root of 10 is a little bit more than the square root of 9. So I'm going to go a little bit more than 3 units. So 1, 2, 3 and a little more. And then I'm going to go back 1, 2, 3 and a little more. So somewhere right there. All right. Last thing for this one are the asymptotes. And again, it's going to be y equals k. Our k value is 2. Plus minus, it's either a over b or b over a, but I know it's going to be x minus h, so x minus 3. All right, whether it's a over b or b over a just depends on what's with the y. I see that 9 is with the y, so that means 9 is going to be my b squared, so that means b is going to be 3. B has to go on top, so 3 over 1. And you can leave it like this, or you can simplify 3 over 1 and say that that's 3. Right, but either way, that's the equation of your asymptotes. What you would do from there, all you really need to know to graph it is where your center is and what the slope is, right? Your slope is whatever's in front, so it's 3. So I'm going to go 1, 2, 3 units up and 1 unit over. And then I have an asymptote right there. And then I'm going to go 1, 2, 3 units down and 1 unit over. And then I have another asymptote right there. And then I know that all I need are my vertices and the asymptotes. And then we get that that is the graph of our hyperbola. All right, so really pretty simple stuff. Just, I mean, I'm sure with all the other stuff, it's a lot to remember. But you're going to see the more you practice shouldn't be too bad, right? Actually finding this information it shouldn't be that bad, right? But we're going to stop right here. I'm going to do the other half, writing the equation, in a separate video.